In topic 4 of chapter 3, we're going to take a look at the conditional and related statements. So we have the converse, the inverse, and the contrapositive. So in many mathematical properties and theorems, we use the if-then form. So any conditional statement, which is the one we have been working with, again, the first part of it is the antecedent, and the second part is the consequent. And P and Q are the letters assigned. Now, if they are interchanged, negated, or both, a new conditional statement is formed. And we can just follow along with what is mentioned here. If you stay, then I go. That's what we had in the previous section. This is a conditional statement following the if-then form. Now, by interchanging the P, you stay, with the consequence Q, I go, we obtain a new conditional statement that is called the converse. So, again, designated the antecedent as P. If you stay, then I go. This is the conditional statement we had in the last part. And if we interchange them, that is, this is the P here again, the antecedent, you stay, then the consequence, which is I go, which is the Q, that is, reverse them. So this now is Q, and then you stay is the P. We have what is called the converse. And there we see it defined. Now, by negating both the antecedent and the consequent, negating them, we get a new conditional statement, which is referred to as the inverse. If you do not stay, there's the negation, then I do not go, the negation. This is referred to as the inverse. So we have the conditional statement, the converse, just switching them around, and then going back to the conditional statement but negating them, we get the inverse. And in this next part, we see if the antecedent and the consequent are both interchanged and negated, then we end up with what is called the contrapositive of the given conditional statement. So, again, this would be Q, this would be P, and they are both negated, reversed and negated. You have what is called the contrapositive. And here is a little summary that you should have in your notes. And they say, notice that the inverse is the contrapositive of the converse. As we look at example 1, we're asked to give the conditional statement and then the converse. So if I am running, that will be your P, and then I am moving would be the Q. So the converse of it would be to put the Q yields P. If I am moving, then I am running. Now, as we look at the truth of that, it may be true, but not necessarily. You may be walking. All right, let's look at the inverse of it. Now, the inverse is you negate both of these. So you are here negating P, negating Q, which would read, if I am not running, then I am not moving. Again, that might not necessarily be true. Now, the contrapositive would be to reverse this order, not Q, yields not P. So if I am not moving, then I am not running. And since they are true, that is true. And we see that the contrapositive, like the conditional statement, is true. And example 1, let's go over this, shows that the converse and the inverse of a true statement need not be true. They can be true, but they need not be. The relationship between the related conditionals are shown in the truth table that follows. I'm not going to read all of the items, but you can use this as a reference. But let's look at the letters here. P, Q. Conditional is P yields Q. The converse, Q yields P. The inverse, not P, yields not Q. And the contrapositive, not Q, yields not P. And there it shows you the truth values. And using your textbook to reference the truth table, notice the conditional statement and its contrapositive always have the same truth value, and the converse and inverse always have the same truth value. All right, we're going on now to what are called equivalences. A conditional statement and its contrapositive are equivalent. Also, the converse and the inverse are equivalent. Again, I'm assuming you're not memorizing these tables, but using them as a reference. Let's take a look at example 2. And if you can do it without looking at the answers, although they're quite obvious here. So for the converse, we're just going to reverse the position of these, and say Q yields not P. So the converse, Q yields not P. Now write the inverse. Well, the inverse is just taking what is there and negating both of them. So that would be not, and you'd have to put that in parentheses, not P yields not Q. And we see that. Now, two knots, I'm not sure you remember this, but two knots make it a positive. So this simplifies to this. So the opposite of a negative makes it a positive. And then the contrapositive, this is what we have. And then we just negate each one of these after switching them around. And notice again now you get the two negatives, which will make that a positive. So eventually this becomes not Q yields P. And they show the steps here. Here our textbook is describing that there are other ways to make statements that are conditional. If P, then Q. They're saying if you take Tylenol, then you will find relief from your symptoms. Perhaps it could be written this way: taking Tylenol is sufficient for relieving your symptoms. And again, they describe this, that I'm not going to read in detail. Going on to another, fresh ingredients are necessary for making good pizza. And again, that could be in an if-then, but there may be other conditions, such as a good working oven, an experienced staff, that could be written in an if-then way. If you want good pizza, then you need fresh ingredients. So, the if-then replaces is necessary. So they're saying sometimes statements can be worded differently, but could be equivalent. So remember, the symbol for equivalence is 3 lines, where this is not exactly the same, but they are equivalent. So we're looking now at some common translations of P yields Q. And none of them which depend on the truth or falsity of the conditional P yields Q. So the most common, if P, then Q. We said we could use P is sufficient for Q. If P, Q, Q is necessary for P. P implies Q, all P are Q. P only if Q. Q if P. And again, as I read it, I'm trying to think of examples and things a little more clear, but we're going to look at some examples now. So we have this first statement, and then we could have other ways of saying it. I don't know if you've heard of the statement plagiarism, where, someone else says something and then we could quote it exactly. That would really be a blatant plagiaristic translation. Or you might think, I could change a few words or change the order. Then it's a little less plagiaristic, and it may be to degree. So you can read those over, and we'll get on to example 3. Now, in example 3, you get your first statement, then they want you to form it in a conditional, traditional form. And we'll pause and let you have a go at it. And example 4 in a similar way. And again, it never hurts to, identify P and Q. So a triangle is equilateral if it has 3 sides of equal length. So here, since this is first, this is where Q is, and then this is where P is. So this is the converse. And in B, this is P, and this is Q. So this would be the conditional statement. P yields Q. And as you do your homework and study and look these over and take notes, this will become easier for you, hopefully. All right, let's go on to the biconditional. Now, bi is a prefix for two, and basically what it refers to is that where normally you think that P yields Q, it's biconditional if Q yields P. And that's the symbol for biconditional. And it's sometimes abbreviated this way, an if with an additional F. All right, we're learning some symbolism here. Now, as we study the symbolism of the conjunction of the conditional, we have P yields Q and Q yields P. And if we were to write that, and the caret indicates that it's an and in order for that to be true, both need to be true. So the symbolism for the biconditional is equivalent to the conjunction of these two conditional. keeping in mind this is an N. The truth table for the biconditional is this. So let's just look at this again to see how it's derived. Here we put our P and Q, and these are both true. And then we say, well, this could be true, this is false. Now this is false, this is true. These are both false. So what would the truth value be of this? Well, if they're both true, we know that is true. If they're both, one's true, one's false, we know that's false. If one is false, one is true, in order to be true, remember they both have to be true, and that's false. And then now you see that both are false. Well, why is that true? Well, it's true because both are false, and then therefore that is true. So think about that for a while. Now, in example 5, they're asking you to use that table that we just looked at to see if these biconditionals are true or false. All right, as we look at letter A, this is true. And if we look at this next part, that is also true. So this is true, and according to the table, this will then be true. Now, as we look at this is not true, so this is false. This is not true either. They equal each other, so this is false. So again, looking at the table, two false, we said, make it true. All right, in letter C, Mars is a moon. Well, that is false. Jupiter is a planet. That is true. But in our truth table, if one is false and one is true, then this is false. And the explanation is here as well. Now, we've come a long way looking at lots of truth tables. Here is a tremendous summary of them. So, for the not P, that is, the negation of P, has truth values opposite that of P. Now here's the AND for the conjunction P and Q. The truth values are only when both of these are true. Now for the disjunction, where the inverted caret is the word or, P or Q, this is false only when both of them are false. Remember, if one of these are true, then it's true. But if they're both false, that's when they're false. Now in the conditional, P yields Q, it is false only when P is true and Q is false. And in the biconditional, the one we just finished, we say this is true when both of these are true or both of them are false. That is, they have the same truth value. Now, I don't expect you to memorize this, but to have it in your notes, and you use it when you are asked to solve this type of question. And I'm assuming we'll have some time in class so that we can look at these, and for each conditional statement, write the converse, the inverse, the contrapositive in the if-then form. And in some exercises, it may be helpful to first restate the statement in the traditional if-then form. So we'll take a look at what we see here, and we'll have some class assignments.